Okay, I've got a truss here, and I basically want to figure out how much load P can I put on this so that this member right here, GF, does not buckle. Has a diameter of 2 inches. It's pin connected, as all trusses are approximated to be. Okay, so there we go. The first thing I need to do is find the force through that guy right there. So what I'm going to do here is going to make the cut right there. Now, from symmetry, I know I've got a P at D, and I also have a P at A, right? Because it's symmetrical, I've got to have those equal loads right there. So I'm going to go ahead and draw my free body diagram. Okay, and then I'll have F, F, G. I'll have F, B, F, and I'll have F, B, C. Okay, then I'll have P acting down here, and I'll have P acting up. Whoops, not B, P acting up there. Now, what I'm going to do is I'm going to sum my moments about point B here. That gets rid of a whole lot of unknowns here. So I'll sum the moments about B, and then from that I'm going to get negative 16 times P, right? And negative 12 up to FG equals 0. From that, I learned that FG is then 4/3 of P, and that's going to be in compression. I'll actually get a negative value, okay, but that negative value tells me my assumption that it was in tension is wrong. It's in compression, and that makes sense. I'm looking for buckling. It's got to be in compression here, but I get 4/3 P as the load acting on that. And again, it's based on P. P is what I'm trying to solve for here, okay? But I needed to find how much of that P is going through that member there. So then I can use my critical load equation to calculate out what that P needs to be. So again, my critical load equation is pi squared EI over KL squared. Okay, so plugging in things that I know here, I got pi squared E. This is steel. It is in English units. So I'm going to use 29 times 10 to the 6 psi for E for steel. I, for a circle, it's got a diameter, is going to be pi over 4 r to the 4th, where r is going to be 1, right? Because diameter of 2, radius of 1. Okay? And I'm going to divide that by KL squared, where K is 1 because it's pinned. So pinned gives you a K. And then L is 16 feet. Of course, I want to take that times 12 inches because I want everything in inches, as I always do, pounds and inches, because I got PSI. My radius is in inches. So I need the length in inches as well. So I'm going to take that times 12 to figure that out. From that, I get P critical equal to 6,098 pounds. Okay, that's how much that can take before it buckles. Now I want to set that equal to my 4/3 P, which is what the load is through that, at least relative to P. And from that I can find that my P, so that this does not buckle, would be 4,573 pounds. So again, we just do what we do for trusses to figure out what the load is through that member, and then apply our buckling equation to figure out what that critical load is, and relate everything back to that load P that I've got going on there.